So in this video, I'm going to discuss the differences between delta y and dy. Delta y is the difference in the y values of two separate points on a line. And I have a graph right here to show you that my math teacher gave me. So let's pretend right here that this is your source point at 2, 5. I'm making this up. Well, the main curve, ignore the tangent line. We're just looking at the normal curve right here that this line is. The delta y would just be the change in y between these 2 points, this one and this one. So it's just taking 2 points on the graph and subtracting their y values to get what the difference in y is. However, dy is the difference between the point and its tangent y value. So aka if there was a tangent line made at this point, it would be the change in y from the point and its tangent line. Now this is how we linearly approximated in the last video. Let's pretend right now it isn't, but let's pretend that this curve is the square root of x. I said if you wanted to find what the square root of 3 was, then find a nice point, which was square root of 4, because we know what the square root of 4 is, and that would be what this blue point is. And then you found the tangent line, which would be a straight line, and we just took what 3 was on this line, because we can do that math in our head easier than the square root of 3. And as you see, it would be a little bit off, but not very much. So that's how we approximated. So that there is the difference between dy and delta y. So, using this knowledge, let's go ahead and do a problem with this, just to show you what the difference is mathematically, not just graphically. So, let's say the problem is, given that the y is the 4th root of x, we're going to want to find, you can't see that, but it says 4th root of x. We want to find what is the change in y and the delta, or not delta, I'm sorry, and the dy as x goes from 16 to 16.1. We know the 4th root of 16. We don't know the 4th root of 16.1. So this would be a case, that's like the last one, where we would be approximating what is the 4th root of 16.1. You can approximate using derivatives. That's not the point of this, but I'm saying that's how you would do it. So, delta y is what we'll do first. Delta y is simply just the difference in what the actual values are. So, this would just be square root of 16.1 minus the square root, 4th root of 16.1 minus the 4th root of 16. I don't have a calculator with me, and I have the answer, but the point is that you're just going to literally put these in, and it's the literal difference in y between when x equals 16 and x equals 16.1. But the dy would be if you did the tangent line and you wanted to know what the height difference would be in the tangent line. And to do this, we're going to need to do some derivatives. You're going to need to find dy dx of this function. Now this, as you know, is the same thing as I'm writing all over the board, x to the 1/4. So it equals 1 over 4 x times, I believe, 3/4, right? I just want to make sure right before I go into it. Yep, 3/4. Okay. I go into something I wouldn't know how to fix. And so this is very similar to the last video. We're then going to plug in the 16 into this. So, dy dx, and this is the notation when you plug things into derivatives. You do a line and then say x equals 16 equals 1 over 4 times, and as you know, with the fraction exponents, it's 16, it's the 4th root of the 16, and then that's the 3rd power. So this is 2 times 3, which is 8, and 8 over 4, so this is 1 over 32. Alright? But we want to find the dy, and this right here is dy dx. So we actually have to then multiply this by dx. Why? Because I probably should have shown you this earlier, but let me rewrite this. That the dy dx equals this, but we just want the dy. So we're then going to just multiply this over, so it's like that. This will come in handy a lot later when you're doing integrals, but basically then we're just going to do, we already know this is 1 over 32, but you're multiplying it then times the dx. Now dx and delta x slash triangle x changing x, they're the same thing, and that's just how much the x is changing. In this case it's by 0.1 or 1/10. So therefore the dy for this problem is 1 over 320. And that's the difference between delta y and dy.